In this video, we're going to discuss other graph features. All right, so the first feature we're going to go over is the y-intercepts. What is a y-intercept? Well, it's when f of x crosses the y-axis. How do we find it? You set x equal to 0 and solve for y. So let's look at an example here. Y equals 2x squared minus 18 over x squared minus 4. So how do we find the the y-intercept? Well, we set x equal to 0, so this is gone and this is gone. So this equals negative 18 over negative 4. The negatives equal a positive, and you can pull a 2 out of here and get 9. A 2 out of here, get 2. So it's 9 over 2, or 4.5 is our y-intercept. All right. So if we were going to start to graph this, which we are going to end up graphing this function by the end of the video, as well as another one. All right, if we were going to graph this, we know our y-intercept would be 4.5. So 1, 2, 3, 4, 5. So we know at 4.5 is our y-intercept. All right. So if we know, from previous videos that we can find our horizontal asymptote by simply looking at the degrees at the top. The degree is the same, so it is our leading coefficients of the top and bottom divided by each other. So our horizontal asymptote is going to be y equals 2. Alright, our horizontal asymptote is y equals 2. So there's our horizontal. Alright, we also know how to find our vertical asymptotes as well. It's what makes our function undefined. Well, we have x squared minus 4, so we know that a positive 2 or a negative 2 will make our function undefined. So our vertical asymptotes are at x equals negative 2 and x equals positive 2. Oops. So there's our two vertical asymptotes. Alright, so here's our y-intercepts. We have our two asymptotes. Alright, so our graph in the middle, to kind of hurry this one along, we'll go over the next one in a little more detail. But to kind of hurry this one along, this part of our graph here in the middle is going to be a parabola that opens upward. Alright, a parabola that opens upward. Alright, now, let's move on and find our x-intercepts. I'm going to group this and copy it to the next page. Next page. So let's go ahead and paste it. Alright, that's not what I wanted to do. Let's get rid of that. I just wanted to move the whole thing over. Alright. So now, how do we find our x-intercepts? Well, first of all, what are they? Well, our x-intercepts are when f of x crosses the x-axis. How do we find them? Set y equal to 0 and solve for x. Alright, so let's write our function back. It was y equals 2x squared minus 18 over x squared minus 4. Alright, well, when you set a fraction equal to 0, the only thing you really set equal to 0 is the numerator. So all we're really worried about is our numerator. Alright, so we're going to take 2x squared minus 18, set it equal to 0, and solve for x plus 18. So 2x squared equals 18. Divide both sides by 2. So x squared equals 9. Take square roots. So x equals plus or minus 3. So this graph actually has two x-intercepts. The first one is at -3. Let's put a dot at -3. And then at +3. So let's put a dot at +3. All right, so now, since our intercept's here, we have an asymptote here and an asymptote here. We know that this graph does this on that side, and I totally missed that. And we know it does this on this side. Get a little better drawn on this thing. All right, because we know that these are x-intercepts. All right, we know those are our x-intercepts. All right, and again, I did this one kind of quicker, but normally what you would want to do is you'd test for things like concavity and other features like that. Okay, so now we're going to look at another problem. Well, first let's talk about symmetry. Sorry, let's talk about symmetry first, and then we're going to talk about another problem. All right, so symmetry. There's three types of symmetry. The first type of symmetry you have is x-axis symmetry. All right, what is x-axis symmetry? X-axis symmetry is if you can plug in x and get positive and negative y answers, it is x-axis symmetric. So if you plug in x and get a positive and a negative y answer, then it is x-axis symmetric. All right. Y-axis symmetry. If you take f of x and you replace x with a negative x, and you get the equal or same value, you have y-axis symmetry. For example, y equals x squared. Right? If you take x, plug in -2, your y value will be 4. If you take and you plug in x as +2, your y value is also 4. So if you take x, replace it with a negative x, and you get the same value for y, you have y-axis symmetry. And then the third type of symmetry is symmetry to the origin. If you take f of x and replace it with f of negative x, and you physically get negative your entire your entire function, then you have origin symmetry. For example, y equals x cubed. All right, if you take x and you plug in 2, y, you're going to get 8. If you take x and plug in -2, for y, you are going to get -8. Since when we plugged in a negative x value, our y value was also negative. Okay. Again, we plugged in a negative x, so we got a negative y. It's the same absolute value, but it's a negative instead of a positive. We got the opposite answer. Therefore, we have symmetry about the origin. All right, symmetry about the origin. All right, so those are our three types of symmetry. All right, if you plug in x and you get a positive and negative y answer, it's x-axis symmetry. If you plug in x and a negative x and you get the same answer, it's y-axis. If you plug in a negative x and you get a negative y, or the opposite of y, then you have origin symmetry. All right. Now, also, calculus also helps you graph some of these things as well. All right. calculus also helps us. If you take f prime and you get your criticals, right? If it changes, okay, if it's changing the sign of f prime, so it's changing the f prime sign, right? Sorry, that's extrema. Right? You get your critical values. If your f prime changes sign at the critical value, okay, that's an extrema. You have increasing, decreasing, all right, meaning f of prime is greater than 0 or f prime is less than 0. These are just quick reviews, okay? Concavity, all right, concavity, f double prime is greater than 0 or f double prime is less than 0. And you also have points of inflection. Points of inflection. If your f double prime criticals, oops, if your f double prime criticals change, wow, I really can't spell today. If they change the sign of f double prime, it is a point of inflection. All right, those are some quick reviews. Your extrema. If f prime is a critical value, if it changes signs at f prime, increasing or decreasing, okay, it's f prime is greater than 0, f prime is less than 0. Your concavity, f double prime is greater than 0 or f prime is less than 0, double prime is less than 0. Then of course your points of inflection, if your criticals of your f double prime change the sign of f of double prime, then it is a point of inflection. Okay, that's what we went over previously. You should remember that. All right, so now let's look at an example, and we're actually going to do all the steps to graph this example. X squared minus 2x plus 4 over x minus 2. All right, first thing we're going to do is we're going to find the y-intercepts. Okay, to find the y-intercepts, what do we do again? We set x equal to 0 and solve for y. So if we set x equal to 0, we basically have 4 over negative 2, which is negative 2. All right, so let's go ahead and start setting up our graph. Get this out of the way. Let's go ahead and start setting up our graph. Here's our x's. I drew that a little high. Let me move that down a little bit. That's good. So we know our y-intercept is now negative 2. Okay, negative 2. There's our y-intercept. All right, let's find our x-intercepts. How do we find the x-intercept? Well, we set y equal to 0. And then we solve for x. So set y equal to 0. Basically, all you do is you solve the top for 0. So x squared minus 2x plus 4 equals 0. Now this won't factor because you have 4 and 1, okay, which will not give you a negative 2, or you have 2 and 2, which will also not give you a negative 2, so this won't factor. And if you try to do the quadratic formula, all right, you have underneath your square root, you have b squared minus 4ac. Well, if you take b squared, you have 4 minus 4 times 1 times 4. So you have 4 minus 16, which is negative 12. So you're going to try to take the square root of a negative number. So therefore, this graph has no x-intercepts, because you have to take the square root of a negative in order to make this equal 0. So we have no x-intercepts. All right, let's find our vertical asymptotes. And yes, that's spelled right. All right, for vertical asymptotes, you take your denominator, set it equal to 0. So x minus 2 equals 0. So x equals 2. That is our vertical asymptote. So 1, 2. Let's draw in our vertical asymptote. All right, I missed. Oh well, I'll fix it. There we go. Vertical asymptote, x equals 2. Now let's find horizontal asymptote. How do you find horizontal asymptote? You compare the powers. All right, so the degree of the top is, if you look at it, it's 2. The degree of the bottom is 1. Since the top is greater than the bottom, no, no, no horizontal asymptote. So we do not have a horizontal asymptote. So not only does this function never cross the x-axis, it does not have a horizontal asymptote either. All right, so now we need to figure out where our graph lies. All right, we need to figure out where our graph lies. Well, one good thing we know is since it never crosses the x-axis, both these sides have to point down, because if either of them go up, we cross the axis. And anything over here will have to be a parabola opening up as well, because if not, it would cross the axis. So now what do we do? How do we find out more points to be able to graph? Well, that's where the derivative comes in. All right, remember the extrema? What we need to do is find some critical points and go from there. All right, so let's take the derivative. All right, well, the derivative of y equals x squared minus 2x plus 4 over x minus 2. Taking the derivative of that, remember it is low d high minus high d low, square the bottom and away you go. All right, so low x minus 2, d high 2x minus 2, minus high x squared minus 2x plus 4, d low, which is 1, over, this is the bottom squared, x minus 2 quantity squared. That is y prime. All right, let's simplify this a little bit. If you multiply both of these through and multiply the negative through at the same time, you should get 2x squared minus 6x plus 4 minus x squared plus 2x minus 4 over x minus 2 squared. It's easier to just leave that alone. Now, when you start combining, you get x squared minus 4x over x minus 2 squared, which will reduce, you can pull an x out of the top, x squared minus 4 over x minus 2 squared. So that's our derivative. All right, this is our derivative. Now, even though we know this has to open down in order for this to even work, because if it opened up, it'd cross the axis, and we know we have no x-intercepts, so we know it can't open up. We know it has to open down on this side. What I would still do is check f prime at 1 and f prime at -1 to tell the concavity, to tell which way it goes. Okay, not concavity, but to tell the slope, to be able to see which way it goes. All right. So f prime, if we plug in a positive 1, if we plug in a 1 in here, this will give us 1 minus 4, which is negative, times 1, which is still negative. Down here, it's going to be squared, so f prime is negative at 1. So what does that tell us? That tells us that it is decreasing at 1. Okay, now put in a negative 1. If you put in a negative 1, you get this is still a negative, times a negative is a positive, and anything down here is positive. So it's positive and negative 1, telling us it is increasing at 1. All right, so let's go ahead and draw that in. Well, if we know it's decreasing here and increasing here, we know this is a parabola that opens down, right? Because it's decreasing at 1 and it's increasing at negative 1. So therefore, we know it opens down right there. All right, now let's find a critical point for the other side. All right, remember our critical points is where this equals 0 or does not exist. We found where it does not exist, and where it does not exist is a asymptote, because it does not exist at 2, or in this case negative 2, but we're not going to worry about the negative 2 because we've already got our asymptotes. So where this equals 0, you set the top equal to 0, so that's either 0 or 2. I'm sorry, that is x. What did I do there? That's just a single x now. It doesn't change the value of this. This is still right, because this is 1 minus, so this is still negative at 1 and positive at negative 1. All right, it's not going to change that. So our critical is at 0 and 4. All right, so we know we have a critical value at x equals 4. We need to find out what our y value is. Okay, so we have a critical at x equals 4. To find out what the y value is, you would plug it back into the original equation. So you'd have 16 minus 8 plus 4, which is 12, divided by 2, which is 6. So at 4, 6, 6, we roll 1 higher. So at 4, 6, we know we have a critical point. All right, and we already know it has to open up, because if it would open down, it would cross the x-axis. But let's just make sure. We know we have a critical point at 4. So let's test f prime is what at 3. When you plug in a 3, this is negative. Times 3 is still negative over a positive, so it's negative at 3. All right, and let's plug in at 5. So f prime is what at 5. Put a 5 in here, you get a 1 times 5, so it's all positive. So we know it is increasing at 5 and decreasing at 3. All right, so decreasing at 3, but then turns and goes back to increasing at 5. Okay, I need to move my 4 over just a little bit. All right, so the graph of y equals x squared minus 2x plus 4 divided by x minus 2 looks like so. All right, I hope y'all followed that. Again, the first thing we started out doing, we found our y-intercept. Our y-intercept, we only have one. It is at x. It is at y equals negative 2. Next thing we wanted to do is we needed to find our x-intercepts. So we set y equal to 0, solve for x. Come to find out, it does not cross the x-axis at all. Next thing we needed to do was find vertical asymptotes. To find vertical asymptotes, you set the denominator equal to 0. So we set x minus 2 equal to 0. Our vertical asymptote is at 2. All right, horizontal asymptotes, you check the degree of the top versus the degree of the bottom. Since the degree of the top was greater, we have no horizontal asymptote. All right, so now we needed to test some points so we could tell if it's, increasing or decreasing, opening up or down. So we took our derivative. Our derivative came out to be x times the quantity x minus 4 over x squared over x minus 2 quantity squared. We tested a point on either side of our y-intercept. We tested 1, it was f prime was negative, so we knew it was decreasing. We tested negative 1, it was positive. We know f prime is increasing. And then we needed to find a point on the other side of our asymptote, so we solved for our critical points. Our critical points were 0 and 4. We already knew about 0, so we tested 4. All right. So we tested on either side. So 3 was negative, made f prime negative, so we knew it was decreasing. At 5, it was positive, so we knew it was increasing. And then to find the y value of our critical point, we took 4, plugged it back into our original equation, and got 4, 6 as that critical point. We knew it was decreasing at 3 and increasing at 5, so we know we had a parabola opening up with its minimum at, with its vertex at x equals 4. All right, so that is what our graph looks like. Make sure you understand this process, what I did, and how we can graph an equation, how we can graph an equation without having a calculator. All right, tomorrow we'll be graphing some of these without a calculator. All right, so you need to make sure you know how to do this. Watch this video again if you need to write down all these steps again. Make sure you understand how to do this before you come to class tomorrow. All right, see you tomorrow.